So let's look at a couple examples of functions that have discontinuities, but they're removable discontinuities, and talk about how we would actually remove those discontinuities. So remember, the definition of continuity tells us that the limit of the function as the function approaches a certain x value and the value of the function at that x value have to be the same as each other. So this particular function is not defined at x equals 0, because if we try plugging 0 in for x, we get 0 in the denominator, and this function is going to be undefined. However, if we look at the limit of this function as x approaches 0, we can do some algebraic manipulation to remove that discontinuity, to get rid of that divide by 0 problem. And the way we would do it in this particular example is we can factor the bottom. And once we factor the bottom, the x in the denominator and the x in the numerator cancel each other out. And we can cancel those, remember, because x is not equal to 0. So we're not canceling zeros, we're canceling numbers that are just really close to 0. And so this limit becomes a limit as x approaches 0 of 10 over x squared plus 5. And now when we try plugging 0 in using substitution, we don't have a problem. We just get 10 over 5, which is 2. So we can find the limit of this function as x approaches 0. And by finding that limit, we know the value of the function also has to equal 2 at that point. So the limit and the value of the function have to be equal for it to be continuous, which means that this also has to be the value of g of 0 if the function is continuous, and we're told in the problem that it is. So we know then that g of 0 is going to have to equal 2. We might see this question asked in a slightly different way. So we might be, instead of giving this information here, we might be given g as a piecewise function and be told, hey, g is a continuous function. Let's solve for k. And so essentially what that's doing is it's saying, find the value of g of 0. So when we plug 0 in for x, what do we get for k? And the work's going to be the same. We're going to find the limit of this value for values around 0, not equal to 0. And that's going to have to equal the value of g at x equals 0. And so that's our k value. So just a slightly different way of asking the exact same question. And so we would get the same answer, g of 0 equals 2. Another problem like this, just for a little bit more practice, we're told here that f is a continuous function for any values of x greater than 1. They're saying greater than 1 here because if x is less than 1, then we run into imaginary numbers, and we are not going to deal with imaginary numbers in calculus class this year. That would be a complex analysis class that you might take in college someday. So if f is a continuous function, and we can see here that we're going to have trouble at x equals 5, then we want to know what is f of 5. Okay, so again, what we want to do is figure out, if we want to know what f of 5 is, that should equal the limit as x approaches 5 of f of x, based on that definition of continuity. So the function has to exist at that point, the limit has to exist, and they have to be equal to each other. So we want to evaluate the limit as x approaches 5 of, and if we try direct substitution here, we are going to get 0 over 0. If we did get undefined, so basically something that's not 0 over 0, we would run into trouble, because then this function couldn't be continuous. We would have an infinite discontinuity. This is a removable discontinuity, though, so we get that 0 over 0, that indeterminate form. We can deal with that here by using a conjugate. So we multiply by the square root of x minus 1 plus 2 on the top and the bottom. So this is going to equal the limit as x approaches 5 of x minus 1 minus 4. And on the bottom, I'm not going to multiply this out. I'm just going to keep it as this. So we have, I'm sorry, I made a mistake up here earlier. This should be x minus 5. So this right here is going to be x minus 5. So we end up with x minus 5 on top, canceling with x minus 5 on the bottom. So what we have left then is a function that we can plug the 5 in. We get 1 over, this is going to be the square root of 4, so 2 plus 2, and we get 1/4. So the limit of the function as x approaches 5 is going to be 1/4. That means that f of 5 also has to be 1/4.